Welcome to the Backyard Professor Math Videos. I'm going to try some math videos. I've been studying math real seriously now for the last, this year. Finally, in my life, I've decided to quit putting it off and to begin studying math real seriously. And I want to share some ideas with you that I'm discovering in algebra, trigonometry, calculus, etc. that I wish someone would have told me when I was in school. I just didn't get it. Either I was too busy paying attention to the girls, or my head was elsewhere if they explained these concepts to me. And now that I've discovered these concepts, I'm going to share them with you because I know people have trouble with algebra. And it doesn't have to be that way. Algebra is not difficult. There's a few rules you have to memorize, but it's not difficult. Let me give you the first concept that I wish someone would have told me when I was in algebra. And it's simple. I'm going to give you the essence of algebra right here, right now. We have a line going across. Woohoo! Now you know why I didn't go into drawing for a living. Underneath this line, we have a pivot point. This is the technological wonder of the teeter-totter. And you go, are you serious? You're going to tell us about teeter-totters? You dang tootin' I am, and here's why. The teeter-totter principle is the essence of algebra. I'm going to assume you know how to add, subtract, multiply, and divide and all that. We're going to start with some basic algebra, and we're going to work into some more complicated materials. For now, what I want to do in this introductory video is give you the essence, the philosophy, as it were, of algebra. This image is an image I want you to burn deep in your mind. Here's why. Let's see if I can get another color or two. The teeter-totter shows equality. That's what we want. We want things to be equal. If you have 5 pounds here on this side, you want 5 pounds here on this side, and it balances. It's equal. If you put another pound here, it's going to go down. And I know, this is simple, basic Mickey Mouse stuff, right? This is the heart of the philosophy of algebra, especially when we get to linear equations. I promise you're going to want to know this. You will think of this image. It goes down and this side automatically goes up, and therefore it's unbalanced. 6 does not equal 5. The idea in algebra is to make both sides of the equation to be equal. So this is your equal sign. This pivot point is your equal. In algebra, we are allowed to do anything we want to either side of the equation. I can add a 16 here if I want to. The rule, though, is that if I do something to this side, I have to do the exact same thing to this side. That is what makes this equal sign accurate. 16 does equal 16. I can do anything I want to this equation. Anything. It doesn't matter what I want to do to this equation, I'm allowed to do it on one condition. Whatever I do to this side, plus 3, I have to do to this side also. Because the law in algebra says we want this equal sign to work. And that's it. That's the essence of algebra, man. And you go, really? It's that simple? It's that simple. I am not kidding. If we decide instead of having 16, if we decide we have 4 plus 1. 4 plus 1. You're not going to write 6 here because 4 plus 1 doesn't equal 6. The teeter-totter is going this way. It's heavier on this side than it's on that side. It's bigger. 4 plus 1 does not equal 6. Your teeter-totter's crooked. Straighten it out. How do you straighten it out? You add another 1. Now this is 4 plus 2. Now 4 plus 2 equals 6, right? Let me show you how to algebraically do a problem. This idea of the teeter-totter is very important for us to get into our minds because the balance. It's all about the balance. I'm going to show you a quick equation. M plus 3 equals 6. Now you already know the answer. I'm well aware of that. We all know what the M stands for. But the question is, why are we using letters in algebra? This is the part that threw me off. Man, when Mr. Thompson, let me see if I can get a darker color here. When Mr. Thompson, my 9th grade algebra teacher, bless his heart, he tried everything he could to bust this stuff into my head, I think. I don't know if I ever even was awake in his class. I don't know. You have A plus 3 equals 7. C plus 9 equals 42. You have Q minus 3 equals 0. And I couldn't bust it into my head. I kept saying, what are you using letters for? Letters don't have any value to them. That looks like a 9, doesn't it? It's supposed to be a Q. Letters don't have any values to them. What are you using letters for? I don't understand what the heck the letters are. A letter is simply a variable. We call it a variable. And the reason why we call it a variable is because we don't yet know the value of Q. We don't know what C is yet. We don't know what A is yet. We know it's a number, we just don't understand its value. It's irrelevant what symbol we use here. It wouldn't matter. It doesn't matter if you want to use a symbol that looks like a star, it's irrelevant. Star minus 4 equals 8. Don't worry about what the symbol is. We use letters in the alphabet. A, B, C, X, Z, Y, M, N, O, P, Q, D, F, R, because we don't know. We know the answer to, let's say, R. I got to draw this right so that you can see it. R plus 3 equals 8. We already know the answer to this because we've memorized it, right? But when we get into more complicated equations, I guarantee you, you will not be able to figure it out without using algebra manipulation. So let me show you with some simple ideas and simple equations how to do the algebra manipulation. It's very simple. Here's how I envision this. The first thing we want to try to understand is whenever we have a letter, E plus 3 equals 8. F, M, Z plus 3 equals 8. It is irrelevant what the variable is, the letter. Don't let that freak you out. Just realize that is a number that we don't know its value, but we know how to find out its value. That's what algebra does. It gives us the tool to discover the unknown value of the mystery number. It's that simple. There's nothing to this. But we need to isolate the letter, the variable. We need to get it all by itself. That's the essence. Without this ability to isolate the variable, we won't be able to solve the equations. So here's the idea. How do we isolate the variable? We have r plus 3 is 8. Someone has come along and added 3 to my variable r. I don't want it to be added to. I want it by itself. How do I get rid of that 3? So that this r will be all by itself on this side of this equal sign. We want this side to be the same as this side. But first we isolate the variable. How do you get rid of a 3? Plus 3. You subtract 3. Why? Because 3 minus 3 is 0. And the 0 you can just simply drop out of the equation. Cool, huh? Yeah. So you subtract the 3, and that isolates your variable. However, the rule in algebra says what you do to this side of this equal sign, you have to do to this side of that equal sign also, right? So we put 8 minus 3. Now, this, the positive 3 minus 3 equals 0, so we can just erase that and have r equals 8 minus 3. And what does 8 minus 3 equal? 5. Now, you know what's cool about algebra? I love this feature about algebra. You can take the answer and plug it right back into the equation. Take your answer when you do your math and put it where that r is. And then do the math. 5 plus 3 is equal to 8. And that's how you know you have the right answer. This works every time with every kind of equation. Let me show you another one real quick. It's a piece of cake to see how this works. And once you see it work, you recognize it's a general principle, it's a general law that you can do. Let's say we have b plus 5 is 50. It doesn't matter what the numbers are. It's irrelevant how big this is. We have a variable, but someone has come along and added 5 to my b. I want the b alone. I want to separate it and have it isolated. How do you get rid of a positive 5? b plus 5, you subtract the 5. Subtract the 5. This will go to 0. 5 minus 5, simple math, 5 minus 5 equals 0, and you don't have to write the 0 in with the variable. So we know we've isolated the b here. The b is all by itself. That went to 0, that cancels out. But we took 5 away from this side of that equal sign, so we have to take it away on this side also. So this equals 50. We subtracted 5 minus 5. You do the math, and it equals 45. Now you take the 45, I put the 45 too low. Stupid professor anyway. You take the 45 and you plug it back into your variable, b. b equals 45, right? So you put 45 here. Your answer, 45 plus 5 is 50. It's that simple. Subtraction is the opposite of addition. Subtraction takes away the addition, and addition takes away the subtraction. Watch this. It's easy once you understand the principle. What if we had 9, no, never mind. What if we had x, and this is the most famous variable in all of algebra, good old x, I'm trying to make it wide, x minus 4 equals 309. Now, we want our x to be alone. The variable has to be alone. How do we get rid? Someone came along and took 4 away from my x. I don't want them to take 4 away from my x. I want my x by itself. How do I get rid of that minus 4? You add 4. X minus 4 plus 4. You added 4 to this side. This equals 309 plus 4. If you add to this side, you add to this side of that equal sign. If you subtract from this side, you subtract the same quantity from this side. It's that simple. There is nothing more complicated than that. Then you do the math. Minus 4 plus 4 is the same thing as 4 minus 4. This is a positive 4, just move it out in front. 4 minus 4 is 0. You don't have to write the 0, so we know we have x by itself. X is going to equal 309 plus 4. Plus 4, because we added 4 here, and that equals 313. Then you take your answer and plug it back into your x. 313 minus 4 equals 309, and that's how you know you got the answer. When something is added to something, you subtract. When something is subtracted from a variable, you add. It's that simple. Isn't that cool? Addition and subtraction are opposite properties of each other. They undo each other. They make our teeter-totter work. They make the teeter-totter work when you have the teeter-totter and something has been added to this side and made it go down. Then if you subtract something from this side, it'll make the teeter-totter go back up and across. That's not very straight, is it, in relation to the frame? If you add something to this side, it's going to go crooked again. So if you add something to this side, you need to add it to this side, or else take it away from that side and it levels out. The idea is we want the equations to be equal in algebra. I think I've just about taken up a half hour for now. Next time I'm going to do division and multiplication and show you how to algebraically manipulate the equations. And then we'll build on equations that are much, much more complicated. The idea here is just to get you to see the algebraic idea of how to do this with algebra instead of in your head, because you just can't do the big tough equations in your head. But if you understand the laws on how to manipulate the rules of algebra, then it doesn't matter how tough the equations are, you can manipulate them. And I will be doing a lot of videos on fractions. Fractions are easy. I will show you some key things to know about fractions that will take the fear of fractions out of your minds. So, anyway, that's my presentation right now. Thanks for watching my video. Have a good life, and